Hello, in this video we are talking about section 8.1 and this is our second day of lecture, so we're continuing our discussion of end behavior, focusing specifically on how to use L'Hopital's rule with evaluating limits of sequences, and then also how to use the squeeze theorem. So L'Hopital's rule does apply to limits with sequences, but you have to be a little careful with your notation because of the fact that sequences aren't continuous functions. They are functions, but they're not continuous functions. So if you have your sequence defined as some function of n, then you need to evaluate the limit as n goes to infinity of a sub n to find the end behavior, but you need to rewrite this in terms of a continuous variable x and evaluate the limit as x goes to infinity of f of x. So this is mostly a notational thing, but it's important theoretically to switch from a discrete function, one that's only evaluated or only defined for n being integer values, to a continuous function so that then you can differentiate like you need to do with L'Hopital's rule. So to see this illustrated in example 4, we're going to determine the limits of the following sequences. Part A, we're looking at Cn, that's defined as e to the negative n times n squared. So we're going to look at the limit as n approaches infinity of e to the negative n times n squared. If you were to consider n going to infinity now, clearly n squared would be going to infinity. But if n goes to infinity, e to the negative n is going to go to 0. Now, 0 times infinity is an indeterminate form. If you recall from Calculus 1, if you get 0 times infinity, you have to divide by the reciprocal of one of your functions or somehow rewrite this product so that it's a quotient, and then you'll get either 0 over 0 or infinity over infinity. From there, you can apply L'Hopital's rule. So the easiest way to write this as a quotient is to simply write the e to the negative n as a positive power. So I mean this is equal to the limit as n approaches infinity of n squared over e to the n. Now, as n goes to infinity, the numerator goes to infinity, the denominator goes to infinity. It's still an indeterminate form, which I'm abbreviating here with IF. But this is an indeterminate form that you would normally be able to apply L'Hopital's rule to. Here is where the notation of writing it in terms of a continuous variable comes into play. So we're going to write this as the limit as x approaches infinity of x squared over e to the x. And now we can apply L'Hopital's rule. So L'Hopital's rule, if you recall, says that you're going to differentiate the numerator, so it's going to be 2x. You're going to differentiate the denominator, which is e to the x. Then try to evaluate this limit. As x goes to infinity, the numerator goes to infinity, the denominator goes to infinity. It's still indeterminate, and it's still a form where we can apply L'Hopital's rule, so we'll do it again. You can continually apply L'Hopital's rule until you get something that's not an indeterminate form. When we differentiate the numerator, we get 2. When we differentiate the denominator, we get e to the x still. Now, the numerator stays at 2. The denominator goes to infinity. If you have a constant over something going to infinity, then the whole thing equals 0. So, in summary, the limit as n goes to infinity of e to the negative n times n squared is going to equal 0. So the end behavior of our sequence here is 0. The terms, as you increase your index, your terms are getting smaller and smaller until they approach 0. For part B, we will look at the limit as n approaches infinity of 3n cubed over n cubed plus 1. As n goes to infinity, the numerator goes to infinity, the denominator goes to infinity. This is a form that you would normally apply L'Hopital's rule for. If you want to do that here, you need to rewrite it in terms of a continuous variable. The limit as x approaches infinity of 3x cubed over x cubed plus 1. Still the infinity over infinity form, so we're going to apply L'Hopital's rule. So we get the limit as x approaches infinity of 9x squared over 3x squared. One thing about L'Hopital's rule, if you apply L'Hopital's rule, simplify first before you apply L'Hopital's rule again, or before you try to evaluate the limit. So if you tried to evaluate the limit now, you would get infinity over infinity, so you'd apply L'Hopital's rule again. But you can save yourself a lot of hassle by simplifying first. The x squareds cancel, 9 over 3 is 3. So we end up evaluating the limit of a constant, which is a constant, so we get that's equal to 3. So in summary here, what we have is that the limit as n approaches infinity of 3n cubed over n cubed plus 1 is equal to 3. Now that would be a solution with applying L'Hopital's rule, but there is an alternate solution. Whenever you have a rational function like this, another way that you can evaluate the limit if n is going to infinity is by dividing by the highest power in the denominator. So what I mean by that is you're going to divide both the numerator and the denominator by n cubed. You could also think of this as factoring out an n cubed from the numerator and the denominator. That would work as well. So in the numerator, 3n cubed times 1 over n cubed gives us a 3. N cubed times 1 over n cubed gives us 1. And then 1 times 1 over n cubed gives us 1 over n cubed. So we have this. Now the reason why this is helpful is with limit laws, you can take your limit and move it to the numerator and the denominator and to each one of the terms in the denominator. The limit of a constant is a constant. The limit of a constant is a constant. The limit as n goes to infinity of 1 over n cubed is going to equal 0. So we end up with 3 over 1 plus 0, or 3. So we get the same final answer, limit as n goes to infinity of 3n cubed over n cubed plus 1. This is equal to 0. But notice we have not differentiated here, so we didn't need to write it in terms of x. So notationally, this method is a little bit easier. But if you don't remember that technique from evaluating limits and you want to apply L'Hopital's rule, that's perfectly fine. But remember to write it in terms of x then. One other thing that I want to see when you apply L'Hopital's rule for evaluating limit is I want you to notate using L'Hopital's rule somehow. Okay, I normally do an L with a circle around it. I've seen a script L, I've seen just a basic L. Okay, you can even write out the whole word if you want so that it looks like the hospital, or if you want to make it a bit more French, you can write it with the accent over the O and without the S. However you want to do it, you can, but it needs to be obvious that you're applying L'Hopital's rule. You need to notate that you are applying L'Hopital's rule. Okay, so we have our two answers for this example then. Remember, when you're applying L'Hopital's rule, make sure you notate it, and also be sure that you rewrite it in terms of a continuous function or continuous variable x.